Hello, so we're going to continue our work in algebra today, and we are looking at exponential functions. And an exponential function is where we have y is equal to something to the power of x, or something to the power of a variable. So it's where the variable, or more commonly x, is in the exponent, is in the indice, or is an indice. So here I have an example of an exponential function. Down here there's another example that we're going to touch on in a minute. But we're going to start up in the left-hand corner of our screen, and we're going to look at y is equal to 2 to the power of x. And I've graphed this from x is -1 up to x is +3. And there's a few things that immediately jump out at me about this function. It's always rising, and I can see that it's getting steeper as the x values get bigger. So I'm rising faster and faster as the x values get bigger. And I can also see that the x-axis looks like it's going to be an asymptote to the function. So this line is going to keep getting closer and closer to the x-axis but never touch it. So those things jump out at me about my graph. Now, we need to be able to draw graphs of exponential functions, and there are two different ways that we can do that. Just like with any function, we can draw a table or we can use our calculator. In principle, they can require you to draw a table, so it's important that we have that skill refreshed in our minds. But more commonly, if you were asked to graph something, you'd use a calculator, because usually time is very pressed in an exam and they're unlikely to get you to do too much table work because it becomes quite repetitive. But I'm going to use it to discuss some ideas about the function, so that's partly why I've drawn it out here. In terms of the structure of our table, we have x in the left-hand column going from -1 up to +3. We have the function in the middle column, and then we have the coordinates that we're getting, our x and y's, in the right-hand column. And if I'm filling it in, I'd have y is equal to f of x, when x is 3 in the piece that I haven't filled in yet. So f of 3 is equal to 2 to the power of 3, which I work out to be equal to 8. So when x is 3, y is 8. So that's how I fill in my table. Now there are some things that I can see immediately here. What's the effect of having negative numbers here? Well, I know that negative powers on numbers mean that they are going to move underneath the line. So if I have 2 to the power of -1, it's going to end up being 1 all over 2 to the power of 1. If I had had f of -2, what effect would that have? Well, it would be 2 to the power of -2. The minus means it moves underneath the line, so that would be 1 all over 2 squared, which would be 1/4. So as my x values are getting more negative, my function is getting smaller and smaller. The y values are tending smaller and smaller, and they will tend towards 0 as x tends to negative infinity. They'll keep getting smaller and smaller by powers of 2. So that is the effect of our negative powers on our function. And another thing that's extremely important, big asterisk we want to have here in our notes, is what's happening when x is 0. Because when x is 0, I have 2 to the power of 0. Now, any number, doesn't matter if it's 2 or a trillion, any number to the power of 0 is equal to 1. So what does this tell me about exponential functions in general? If I have the function here, and I have any number to the power of 0, it's going to equal 1. So the exponential part of any exponential function is always going to be 1 when we are crossing the y-axis. Now in a few minutes we're going to touch back on why that's important and how we can use it to help us with understanding functions, with understanding these types of functions. But again, anytime x is 0, the exponential part of our function is going to be 0 if we have a simple function like number to the power of x. Now, after that, it proceeds basically as you'd expect, x to the power of x is 1 gives 2 to the power of 1 is 2, x is 2 gives 2 to the power of 2 is 4, and as we did, x is 3 gives 2 to the power of 3 is 8, and we write out our x and y coordinates. And that's how we work out our function in terms of a table. Valid and important method to have. And it can be helpful in reasoning out questions as I've highlighted here. However, the more common way to do this is going to be with a calculator, and what I've done is written out the steps for a Casio calculator. Unfortunately, Sharp calculators do not do this well. So if you don't have a Casio calculator, I recommend you get one, because it's going to be very helpful for functions type questions and graphing type questions in the exam. So this will make a lot more sense if you have your Casio calculator in front of you. You press the setup button, then there'll be options, and you're going to press number 3 for table. You'll get something that says f of x equals, and in this case we want 2 to the power of x, so we're going to go 2 x to the power of, then alpha, which is a button we don't often press, that gives the red letters, that activates the red letters on our keys, and then we're looking for red letter x. We hit equals, and then we're going to get into screens that say start, and we're going to start at -1 because we want our smallest x value at -1. End, when we hit equals again, when we hit equals again, we're going to get end, and we want to end at 3. And then our hit equals again, and we'll get step, and we want to run in steps of 1. So x is changing by 1 each time. Then when we hit equals, we will get a table that looks basically the same as our coordinate type table. And we can use that to draw our graph. And to go back from table mode, from function mode, to the normal way that we work our calculator, we press setup again. When we're done with our table, we press setup and then 1 for comp. So comp is what we usually use our calculator in. Now, that's what I've used in order to produce this graph here. So I have y is equal to 1/3 to the power of x. And I've gone through a little bit of changes here to remind you of your indices work. So that is going to be, I have a power on the bracket here, so it's going to put a power on everything in here. So I end up with 1 to the power of x and 3 to the power of x. Now, 1 to the power of anything is just 1, so I don't bother writing the power of x on here because it's not going to have any effect. So I end up with 1 all over 3 to the power of x, and I know from my indices rules that that's going to be 3 to the power of -x. Now, what effect is that going to have? Well, it means that as x becomes positive, I'm effectively going to end up with negative powers. X to the power, when x is 1, I'm going to end up with x to the power of -1, which is 1/3. So I end up with 1/3. When x is 2, if I had f of 2, I would end up with 3 to the power of -2, which is 1 all over 3 squared, which is 1/9. So I would end up getting even smaller. And if I had f of 3, I'd have 3 to the -3, which would be 1 all over 3 cubed, which would be 27. And just for completeness, if I had f of 1, 3 to the -1 and is equal to 1 all over 3 would be 1/3. Now, something to notice here, when my number here is bigger, when my base number is bigger, I end up with the function changing value more quickly. By x is 3, I'm at 27th. By x was 3 here, I was only at 8. So because the base number is bigger, my function is changing more rapidly. Now, the effect of that can be seen in this sketch up here in the right-hand corner of the screen. Now, I want to interpret as much as I can from this sketch. The first thing that jumps out at me here is by x is 1, I'm rising very, very rapidly. This line is becoming very vertical very quickly. So I'm thinking that I know that I've got an exponential here because of the general shape of my function. It's seems to be an asymptote to x, the x-axis, and it's rising constantly. So I know I have some kind of exponential function. Y is going to be equal to a to the power of x, where a is just some number. Now, there's some, what do I know about a? Well, I know that a has to be positive because my line is going upward. Sorry, I know that a is greater than 1, I should say, because my line is going upward. When a number is less than 1, I would end up with my line going downward. So if my value of a was between 0 and 1, I would end up with a decreasing function. If my value for a is greater than 1, I'll end up with an increasing function. And the bigger the value of a, the faster my function is going to increase, the steeper my blue line is going to be. So I can tell from my graph that a is greater than 1 because it's rising. And what else do I know? Well, I've been a little bit dishonest with you in that this isn't actually the exact form of this equation, because if I look at where this is crossing the y-axis, I can see that it's crossing at y is 3 instead of y is 1. But I know that the exponential part of my function is going to be 1 when x is 0, because any number to the power of 0 is 1. So this tells me that my function must be multiplied by 3. Why does it tell me that? Because when x is 0, y is 3. So if I sub in x is 0, I know that when x is 0, y is 3. Y is 3. We'll say there's some constant here. Some constant and multiplied by a to the power of 0. Well, a to the power of 0 is just 1, so I end up with 3 is equal to k. My constant must be 3. Now, something that might have immediately jumped out at people is what I'm doing with this dot. This is called dot product, and if you do maths in college, you will come across it a lot. It's technically how you write multiplication between something called vectors, which you might have touched on in physics. In your books and sometimes in the exams, they will use something that is a full stop for dot product, which they technically shouldn't do. Dot product should actually be written as 3 dot a to the x. That's how that ought to be written mathematically. In the exams and in your textbook, it will often be mistakenly written or slightly incorrectly written as 3 dot a to the x, which can get annoying because you can also end up with a being a decimal. So you could end up with y is equal to 1.3 to the x. And you're expected to know when it is multiplying, when it is not, and it's to do with where your brackets are going. So this would mean that 1.3 was to the power of x, whereas this would mean that the power was just on the 3 and you were multiplying it by 2. I'm aware that this is a little bit annoying, but I'm highlighting it to you as something that you are going to deal with. So those are our different bits and pieces for an introduction to exponential functions. So you can see their general shape, and you can see that by looking at where they're crossing the y-axis, we can interpret what number the exponential part is multiplied by. And we've done a little bit of a reminder on how we graph our functions. So our exponentials work like this.